Alright, I will be proving theorem 5.3 with the Archimedean property of the real numbers. Alright, this theorem says that for any AB element of the reals where A is greater than 0 and B is greater than 0, there exists a n element of the naturals such that n of A is greater than B. So to prove this, what we're going to do is to say we're going to do a proof by contradiction. So we will argue that assume that for all natural numbers, n times A is going to be less than or equal B. So this means that the set S, which is equal to all of these n times A, such that n is an element of the naturals, is bounded above by B. Now, by the completeness axiom, we know that there must be some supremum to that set S. And just to make sure it's clear here, I'm just going to call it S with these little markings here. So I'm going to define supremum of that set by S sub 0. And I know by the definition of that, I know that for all n A has to be less than or equal to S sub 0. And I also know that since A is a positive number, S sub 0 minus A is less than S of 0, and by the definition of S sub 0 being the least upper bound, I can always find some element of my set, which I'm going to call n sub 0 A, such that that number is less than or equal to my least upper bound S sub 0. But of course I have this inequality here, which says the following. If I just look at this, S sub 0 minus A is less than n sub 0 times A. Now if I add A to both sides, I get S sub 0 is less than n0 plus 1 A, since I've added A to n0 times A. Now we know that n0 plus 1 is an element of the natural numbers, and so this actually means that n sub 0 plus 1 times A is an element of the set that I defined up here, but then this element of this set is now greater than S sub 0, which I said was the least upper bound. So S sub 0 cannot be the least upper bound. And I have a contradiction. And so this means that it must be the case that there exists some n times A that is greater than B. And I'll just write this conclusion here. Therefore, there exists an n such that n times A is greater than B. So that is the proof of 5.3.